Welcome to an introduction to chemistry, brought to you by Parkbench Tutors. For more information about Parkbench Tutors, just look us up on Facebook. In this podcast, we are going to look at Lewis dot notation. We regard atoms as being made up of particles, and we say that the nucleus of an atom can contain two types of particles, protons and neutrons, and that in orbit around this nucleus are a series of electrons. And with Lewis dot diagrams, we're only concerned with electrons, and in fact we're not even concerned with all of the electrons. So what do we mean by Lewis dot notation? Well, we represent everything except the electrons that we're interested in by what we call the kernel. In other words, we just use the symbol. And we say that the kernel is the nucleus and the inner electrons. And so it's the valence electrons which are then represented, and we represent these by means of a series of dots. And if we write down the elemental symbol, there will be four sides around the symbol, and each one of these we can say represents an orbital in a valence shell. So the rules for orbitals are still going to apply. No one side can have more than two dots, and each of the p orbitals will get one dot before you can double up. So here's a typical Lewis dot diagram representation. X represents the elemental symbol, and then around it on this one we have an s orbital, and we have three p orbitals which we've labelled p1, p2 and p3. And the only other thing that I want you to bear in mind at this point is that we could place the s orbital on any side of the symbol, but it helps if we stick to a pattern. So the pattern I'm going to try and stick to is to try and remember to place it on my left. So let's look at something like beryllium as an element. It has an atomic number of 4, so it means there are 4 electrons. So these electrons are arranged in the s orbitals, so we have 1s2, 2s2. In other words, the nucleus and 2 electrons are in the first energy level, that's 1s2, and they make up the kernel of the atom, and we can represent those by the symbol, and the other 2 electrons then represent the second energy level, which is the 2s level. And we can now represent these valence electrons by dots in a Lewis dot diagram. So I start with my elemental symbol, beryllium, Be, and I start putting my dots in. There's my 2 for my s orbitals. So I've placed the 2 dots on the left because that's where I said I was going to put the s orbital. There are some useful references for you. One is you should try and remember the order in which the shells, the orbital shells, are filled up, and this shows 1s, 2s, 2p, 3s and so on. All you do is follow the blue arrows there. So let's look at something like carbon. Atomic number 6, and the electron configuration 1s2, 2s2, 2p2. So the valency shell is going to have 4 electrons, that's the 2s2 and 2p2 orbitals. So we'll stick with our idea of filling the s shell to the left. So I start with my symbol, put in my electrons for my 2s level, and then put in 1 each for the p's. So now I've got 4 electrons, 4 valence electrons around my symbol. So how about another of these? Let's take phosphorus, and there we have phosphorus. We can find it. It's element number 15 in our periodic table, atomic number 15. So we've got 15 electrons to account for. Right, we've seen the order in which orbitals are filled. What we also need to know is how many electrons you can put in each orbital. In the s levels there is 1 orbital, which means that you can have 2 electrons. You can have 2 electrons per orbital. In the p levels there are 3 orbitals, so you can have a total of 6 electrons. The d5 total number of 10, and you can see that you've got a pattern here. We're going up in odd numbers, 1, 3, 5, 7 for s, p, d and f, and the number of electrons will be twice the number of orbitals. So for phosphorus, we'll put that together and say that we've got 1s, that's our first level, 2 electrons in it, 2s, 2 electrons in it, 2p, 6 electrons in it, and 3s, we've got 2 electrons in it, and 3p, we have 3 electrons in it. So if I add those up, 2 plus 2 plus 6 plus 2 plus 3 is 15. Now, where's the kernel? Well, the kernels are the lower energy levels here, so we're only interested in the upper energy levels, which is the 3s and 3p, our third level if you like. And so those are our valence electrons, and there are 5 of them to arrange in the Lewis dot diagram. So how are we going to do this? Here we are. We have the 2 electrons for the 3s level, and then we have 3 electrons for the 3p. So why show the p electrons on different sides? Well, sides, and the answer is in fact they all obey what we call Hund's rule. And what Hund's rule says is that if there's an empty orbital, then we fill the orbital up with 1 electron until we need to double them up. So if we have 3 orbitals and each can hold up to 2 electrons, to fill them up we first fill 1 in each, and then we double up and start putting 2 in each until the orbitals are full. Okay, what about something like sulfur? So here we are. Sulfur is atomic number 16. There we are, there's its place in the periodic table. So we put the table and chart together for 16, and we can see that we filled up 1s, 2s, 2p, and in the 3s we filled that up with 2 electrons, and 3p they're going to be 4 electrons. So I add that up, 2 plus 2 plus 6 plus 2 plus 4 is 16, so I've got my 16 electrons. And my kernel will be the 1s, 2s, 2p, and my valence electrons will be in 3s and 3p. So we apply Hund's rule, we find an empty orbital for each of the p electrons until we need to double them up. Okay, so we're going to have, if the first p orbital will have 2 electrons in, and the next 2 p orbitals will only have the 1 electron in. That's how we're going to deal with sublevel 3p. And there we are, there's my Lewis dot notation for it. My 3s level is filled with the 2 electrons. One of my p orbitals is filled with 2 electrons, the others only got 1 electron in each. So, just how did we get these valence electrons, right? Well, the valence electrons are those in the highest energy level, right? And they determine the reactivity. And as far as chemistry is concerned, those are the electrons that we are normally concerned with. There are lots and lots of energy levels, but for the most elements we're only interested in the first 4 levels. So if we look at the energy levels here, we can have 1s, 2s, 2p, 3s, 3p, 3d, and so on, and I've shown the number of orbitals for each and the maximum number of electrons that you can put in each of these. So we'll put it all in order. We've got a Lewis dot configuration for element X. So first we find the atomic number by looking at the periodic table or other list. Then we determine the number of electrons. We write the electron configuration. We determine from the electron configuration number of valence electrons, and then we can draw out the valence electrons on the Lewis dot configuration. So we look at nitrogen. Nitrogen then has atomic number 7. So here we are, atomic number 7, number of electrons 7. So the electron configuration 1s2, 2s2, 2p3. The higher energy level is 2, so those are the electrons that we're interested in. So the valency electrons are 2s2, 2p2, that is, we've got 5 electrons which we need to place. So we can now draw our Lewis dot diagram. And there we are, 2 in the s level and 1 each in 3p orbitals there, and those are our 5 valence electrons. How about something like calcium? Atomic number 20, number of electrons 20, so what's our electron configuration? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So the valency electrons are those in the highest level, and the highest level is going to be the 4s2. There are only 2 electrons there, so we'll have a valency of 2. So we can draw in our Lewis dot configuration. It's simply going to have 2 electrons there. Take something like lithium. Atomic number 3, number of electrons 3, the electron configuration 1s2, 2s1. We can see that the higher energy level there is the 2s level. There's 1 electron in it. So to write the Lewis dot diagram, I'm just going to put 1 dot by the lithium kernel. If we look at the periodic table, we can see that there are patterns to them, and we've coloured the pattern here. So we have, if you like, a pink pattern, a green pattern and a blue pattern. And in the pink block the S levels are filling, the blue block the P levels are filling, the green block the D levels are filling, and in the last block the F levels were filling. That's the end of this session on Lewis dot diagrams. We hope that you are successful in your studies. Thank you for watching and for listening. If you want more information on Parkbench Tutors, look us up in Facebook or look us up on parkbenchtutors.com.